don't know how that's hard.
Okay, so let's chit chat about a couple of these problems. On 46, we're oddly enough, you're cooking the hot dog. Okay, y'all have a good visual on that at that point. That's why I did that. It should take a little bit under 2 minutes. So on 46.
Where the heck did my assignment go, bruh?
Like 93 seconds? 94 seconds?
Maybe around 100 seconds.
Okay, that's.
I lost my assignment.
It's the same thing.
How did you lose your assignment?
I don't know what happened to it. Like, I thought it was a.
Did you give it to anybody?
No.
Did you turn the whole 30 seconds right
Is it
there?
in your backpack?
No. It should be in here.
Did you take it out?
Okay, anyway, back to our story. Now, let's talk about 50 in terms of it's kind of a cool, like, physics meets biology. So on 50, basically what we're talking about is like, okay, you put your hand on something hot. How does that information get transmitted from your fingers up to your brain that says, wow, this is hot?
Your nerve.
Your nerves, okay? But basically, so what's happening on 50, you're saying, all right, then what has to happen is that it has to be an exchange of ions. And so there's like a sodium potassium pump, and it's usually like represented by like a spinning wheel, and the sodium ions fit in one, and this wheels, and then you establish this equilibrium. So conveniently, that nerve signal gets transmitted very, very quickly. It isn't like you put your hand on something hot, and then like 30 seconds later, your brain gets the signal that says, wow, that's a hot plate, okay? Because by then, it's too late at that point. So conveniently, we get nerve transmitted very, very quickly. And so it's basically like a current. Oh, we're going to transmit this through. So what happens is that you have an exchange of ions. And so basically, when you get what's happening on 50, monovalent, don't flip out, and we're going to see this term again when we do magnetic fields. Monovalent just means that it's either positively one charge or negatively one charge. Mono just means one, okay? That's all that means. So if you look at what you're given, you have 1.0 times 10 to the 7th ions per second. That's a lot, okay? Okay, that's like 10 million ions per second. That's a lot of ions that are being transmitted. Now, this is also a classic example of significant digits. You have 1.0 times 10 to the 7th. That's about 10 million, okay? We're not saying it's 1.053215, okay? We couldn't measure precisely that many ions. It isn't like we can sit there and count them as they go by. It isn't like, oh, here's the fence, and we open up the gate, and we count how many sheets are running through the gate per second, okay? Can't do that. So it's like, it's a ballpark. It's 1.0 times 10 to the 7th ions per second. So, you know how many, you know the charge on each coulomb. So you're going to figure out what the charge is per second. So that should be like 10 to the negative 12th. And then you want to figure out the potential difference, 70 millivolts. What's the power dissipated in the channel? So remember, power is going to be measured in watts. That's joules per second. And so that answer should be something times 10 to the negative 13th watts, okay? Which isn't very much, okay? On 68, with that one, you're trying to figure out, number one, is it safe or not? You're just going to find that current in the two different situations, and as the old saying goes, it isn't the voltage that kills you, it's the amperage. So like when we fire up that Van de Graaff generator, that might be 50,000 volts, okay? But it's a tremendously high voltage, but it's very, 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 very low amperage, okay? Now, if you have a combination of very, very high amperage and very, very high voltage, that's when bad things happen, okay? Well, depending upon the situation.
limit for.
So you should see on 68, that first one,
There's a little.
in milliamps in milliamps should be less than 1, and on 68B with your milliamps that should be above 100. On those multiple choice questions 70 through 73, none of your answers should be C.
I got,
So
hey,
what's
it's 72A.
72? Wait.
Maybe.
Okay.
Whoa, no, you did not say 72 was B.
He just said none of the multiple.
I said
choices.
A.
You
I
did
just
not
said none on 70 through 73,
Okay.
none of them are C.
You just said it, so.
How's it A?
It's B.
Maybe it's not A though. Don't take my word for
I
granted.
should've-
Yeah, what
Is it A?
what's 72?
Well, it could be B.
Oh
All
yeah, it
I'm
could
telling
be
you is
B.
that it's not C.
Or B.
it A?
No, it's B because it has to start with 0, right?
Oh, so it is A. He didn't make that face when I asked him if it was A.
Open the book, open the book.
Alright. Well, now we know the answer to that one.
Wait, can you
Yeah.
explain it though? Because I was kind of confused on those. Not gonna lie.
On which one?
Like the whole thing.
72.
Honestly, 70 through not 70. 71 through 73.
Okay,
Cause like I kind of get that it's the inverse
hold on.
of it or
Just
something.
hold on.
Wow, I got 72 right, but I got 71 and 73 wrong.
It's okay.
Like when I checked it in the book, I don't know, I was like, oh, that's awkward.
Okay. So here's the story on 71. So what you're told, and this is like the old style of light bulbs. Okay? So you can make the analogy with this filament and you're trying to pass current through it, is that when you first turn it on, and here is the disadvantage of these old style light bulbs. And this is why they're so inefficient, and this is why they're trying to phase them out. It's because you obviously get light out of them, which is cool. But you also burn a tremendous amount of energy that's lost in heating up the filament. Okay? So this is why when you turn them off, the old style, they would actually see them glow for just a little bit afterwards, because those filaments were so hot they would still produce thermal energy because of the fact that they were so hot. So yes, you were getting light out of it, but out of the expense of having wasted a tremendous amount of energy on heat. So the advantage of LED lights is that you get the light, but you're not wasting near as much energy on the production of thermal energy. So you get the advantage of the photons, but you're not wasting energy in the production of the heat. So that's the main thing. So then it said it starts off cold, right? Power dissipated I squared, da 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 da. So 70A is just ver it up. Okay, you're just going to try and find the resistance. So you got the voltage, and then you're going to try and find that resistance. Easy peasy. So then when you get to 71, the resistance of the filament, okay, because that filament is getting warmer, so it becomes like a negative feedback loop. So the filament starts off cold and then it heats up very quickly, okay? So then as it heats up, the resistance is going to increase because of the fact that as those particles that make up that filament heat up, they vibrate more. So it's harder to get those electrons in that field to get transmitted through it. So it's like the anti-superconducting material, because it's going to warm up. The more it warms up, the more the resistance is. So it becomes just like kind of like this vicious cycle. So that's why 71 is, hey, the resistance is going to increase. Now, when you get to 72, so, and the whole key to 72 is that expected variation of the current as a function of time in the short time interval immediately after the bulb is turned on. So because of the fact with this one you're going to be talking about current, so it can't, the reason the fact that you're talking about after it's turned on, so you're assuming that that resistance is already there. So that's why on 72, that curve is A, because of the fact that you're talking about it after it's been turned on. So this is after you've already introduced some current into it. And so that's why it's A and not C. Okay, so if it said, oh, at time 0, and you're including that, from before you turn it on to afterwards, then it would be C. But because of the fact they're talking about after it's gone on, so as that's heating up, that current is going down. Does that make sense?
Yeah.
Okay. Anything else? Once, twice, sold? Okay. Get that handed in. Okay, so a couple of things on Monday and Tuesday. Unfortunately, I'm going to be gone. Ironically, I'm going to be in DC talking about electricity and solar. And so it's kind of a win-win for everybody involved. So today is very much a good news, but it's just good news all the way around. So, because it's going to work out better in terms of not so much what's going to happen Monday and Tuesday, but what's going to happen Wednesday on a big lab that we're going to have to do. So here's what's going to happen. So today, now that you all know enough about this, there's a couple of short videos that I want to watch on batteries and big electrical power plants. So now you all know enough about it to go, oh yeah, now that all makes sense. So we'll watch those today, so you won't have any homework over the weekend, okay? Then on Monday, I'm going to come, what's going to happen, Sub's going to be here. You're going to have the first lesson out of chapter 23, which is actually on circuits, okay? So,
On Monday?
on Monday.
Oh man.
On Monday, you'll have your first assignment out of chapter 3, which is actually on circuits, okay? So, I'm going to record a lecture. She's going to play that on Monday. You're going to have an assignment. It's just going to be like you normally would. Tuesday, you're going to have the first lab on circuits, okay? And again, she's going to come in. You're going to watch a video. I'm going to record these tomorrow. You're going to play that on Monday, then on Tuesday, and then on Wednesday, we've got another big lab to do on light bulbs. So it's just going to, because I did that light bulb lab, I really need to be here to explain that because I need to help you through some stuff. So that's why I'm going to kind of space this out a little bit. So we'll watch the videos today. We'll start circuits on Monday. You'll have that circuit lab on Tuesday. And then I'll be back on Wednesday, and then that's just going to flow, make everything flow more nicely. Now, I realize there's a 99.99% chance that it's not going to happen. But the worst thing that can happen, and that's why I said there's a 99.99% chance it's not going to happen, is that I get a text from her or I get a note from the sub going, man, your kids were turds. So help me God. So help me God. You talk about the wrath of Burkamp like you have never experienced in your entire life. Oh, dear Lord.
Worse when you caught
Oh,
Papa and Vito
oh,
talking
that was calm.
That was
That
scary.
was calm.
I'm not gonna lie.
Okay? That on a scale of like 1 to 10, that was like a 3.
Oh,
This would be like a 10.
Wait,
Okay.
did you expect us to like not be good?
No, that's why I said there's a
I know.
99.99% chance. But you're a teenager, and every once in a while, wires get crossed in your brains, and you think, oh, let's do something stupid, okay?
Oh, that makes sense actually.
Okay.
They've done
Bob,
some
with
dumb
the
things.
forks.
That's why I'm just telling you, if you're thinking
You
about
probably
doing
should-
something
Hey, don't worry, we'll be
stupid,
good.
don't.
You should probably put up the tuning forks.
I am, actually. That's why I've got them gathered back there.
No. I think Papa.
So, that's why I put away all the tennis balls, I put away the tuning forks, and I've popped all the balloons.
All the balloons?
I'm
Yes,
going to wine glasses.
You gonna blow them back up?
just
I'm just playing. Just keep it
to
down.
avoid that potential. So, anyway, so we'll stop that. We'll just show out, get some pretty cool videos. Now that you know enough about batteries, now this will make sense. So, let me get these fired up.
Okay.